-2. Right now, you guys, I'm recording, so I'm repeating, guys. You should be working on your odd problems. I'm going to work some even problems that were assigned on Thursday. End of the current flip chart. And we're going to work 24 and 26, and then Aiden will be able to do 25 on his own. All right, so this is one, Aiden, I think we did 24, so we'll do 26. We did 24 on Thursday, so let's do 26. So what I would do, if you'll remember, that 8p to the 1/6 power is really 8 times p to the 1/6 power. Does that make sense? And when it's times 5m to the 1/2 power, that's really times 5 times m to the 1/2 power, and this keeps going all the way. So what I find helpful is if you put all of the numbers with no variables together, all the factors with no variables together, and all of the variables, the like basis ones together, right? So I'm going to go through and reorganize this. So this is going to be 8 times 5 times 8 times 5. So I've transferred all that. Does that make sense? Mm-hmm. And now I'm going to put my p's together. I've got times p to the 1/6 power times p to the 1/4 power. So I've got all my p's included. Then it's times m to the 1/2 power times m to the 5/6 power. So I'm going to do that on my calculator, and I think it's 40 times 40, which I think is 1600. 40 times 40, so that's going to be 1600 times p. Now, if we have like bases, do you remember how we multiply those? If we have like bases, what's the shortcut? Adding the exponents, remember? So on your calculator, we can add those exponents. Remember how to use the fraction buttons on your calculator? So it's 1/6, so it's 1 ABC6 plus 1/4, which is 1 ABC4, and equals. Now we know that that is p to the 5/12 power times m, and we're going to add those exponents. The shortcut to multiplying numbers or variables with the same base, that same number that's being raised to a power, so we can just add the powers. So the same thing on my calculator, 1 ABC2 plus 5 ABC6. That's 1 1/3, but I don't want to mix numbers, so I want to hit 6 and the F to, no, actually 6 and the ABC number again. So now I know it's m to the 4/3 power. Oh, that's 1600, not 60. Not 160. Fix that. And that's p to the 5/12. Does that make sense? So reorganize number 25. Put all the numbers together, then put the k's together, then put the h's together.
Is that m and 3/3?
5/12. Oh, the m is 4/3. Yep. Mm-hmm. Anybody else have one that you want me to do, like something on the odds? You have a problem on the odds, you want me to do one of the evens like it? So I can help you get started. Sydney, you got to be working on something. You hear me? Sydney? Your pencil should be in your hand. You got to be working. Caleb Berry? 17. All right. Well, let's do 16. Because it's going to be similar to 17. So we're going to write each answer in scientific notation. Here it says the population of a country in 1950 was 6.2 times 10 to the 7th power. So that's the population. Just kind of organize it in my mind. Actually, I'm going to give myself a new page. .2 times 10 to the 7th power. The population in 2030 is 3 is projected to be 3 times 10 to the second power times the 1950 population. So we're going to be multiplying this expression by 3 times 10 to the second power. Does that make sense, Caleb? So that's what we're going to do. So this is the 1950. It says the 2030 is going to be equal to the 1950 times 3 times 10 to the second power. Really, that's 300 times, right? Because 10 squared is 100 times 3. But this is the same thing as 6.2 times 10 to the 7th power times 3 times 10 to the second power. Does that make sense, Caleb? And now I'm going to put these together. So 6.2 times 3, and that's going to be times 10 to the 7th times 10 to the 2nd. So I put these together because these have like bases, right? These we're just going to multiply on our calculator. Does that part make sense, Caleb? So that's what we're going to do. So 6.2 times 3 is 18.6. And what is this going to be, Caleb? 10 to the what? Perfect. We're adding those. 10 to the 9th power. The problem is, we get here, Caleb, and this is not in scientific notation. Do you remember what we said about this number? What's it have to be? You can look at your notes. This number, if it's written in scientific notation, this number has to be within a certain range of values. What's the range of values it's got to be? It's going to be greater than or equal to 1 and less than what?
Less than 10.
10. This is greater than 10, so that won't work. So we're going to rewrite this. We're going to move this decimal point back. That's 1.86. This number is greater than 1, so I know. Now I'm going to rewrite it in scientific notation. So I moved it back 1. It's got to have a power here, so this is going to be a power of 1, so I only moved it back 1 spot, so I put a 1 up there. Since this number was greater than 1, that's a positive number. If that were 0.186, I would have given it a negative 1. Does that make sense, Caleb? Okay. So this represents this number. So now I can't forget to include this in my answer.
So that's a 1.
So it's going to be 1.86 times 10 to the 1st times 10 to the 9th power. So the final answer would be 1.86 times 10 to the what power?
10.
Yeah, we add those. The shortcut is to add the exponents on a like basis. And if you want, we can do number 17 together, Caleb, but I'm going to let you try to help me rather than me try to help you, okay? Does this one make sense?
Yes.
Caleb? Okay. Aiden says yes. Caleb says yes. So let's go back here. Now this one says an area of land in Rhode Island covers 1.5 times 10 to the 3 square miles. So why can't I remember a number that I just looked at? 1.5 times 10 to the 3rd. So that's the area of land. You're writing what I'm writing? It says that the area of land that Alaska covers is a little more than 4.3 times 10 to the 2nd power times that. So it's not 2 times that, it's 4.3 times 10 to the 2nd power times that. So we're multiplying again, right? If something is 2 times bigger, we multiply by 2. If something is 10 times bigger, we multiply by 10. If something is 4.3 times the 10 to the 2nd power bigger, then we multiply by that. Does that part make sense, Caleb? All right. 4.3 times 10 to the 2. this is Rhode Island's area. And Alaska's is Rhode Island's times this. So this is times bigger. So what am I going to multiply, Caleb? Can you tell me what I'm going to write to multiply? So Rhode Island is little. This is its area. Alaska is big, right? Alaska is really big. It's a lot bigger than Rhode Island. In fact, it's this many times bigger. 4.3 times 10 to the second power, that's 4.3 times 10 times 10, that's 100, right? So we're saying it's 430 times bigger, but they don't want us to multiply by 430. They want us to multiply by this expression. So tell me what to write to find out how big Alaska is in scientific notation. Say that again? Oh, I can, if you like. So we want to find out how big Alaska is. We don't know how big Alaska is. We know how big Rhode Island is, and we know that Alaska is 4.3 times 10 to the second times bigger. So how can I find out how big Alaska is? What can I write? Let's pause first. Go ahead. No. Let's think about it this way. What if Rhode Island were 50 square feet? So let's forget this for a second. So if Rhode Island's area was 50 square feet, and Alaska was 3 times bigger, how would I find out how big Alaska is? 3 times what? Right. So if Rhode Island was only 50 square feet and Alaska was only 3 times bigger, you know that we'd take 50 and multiply it by 3, right? That's what we're doing here. We just have these big ugly numbers. But it's the same thing, all right? So now for Alaska, you're right. It's whatever Rhode Island is, but Rhode Island's not 50. Rhode Island is this expression. So it's 1.5 times 10 to the third power times what? How much bigger is it? Times 10 to the second power. Very good. 4.3 times 10 to the second power. Is that what you were going to say, Aiden?
Yes.
Nice. All right, so now we're going to rearrange things. Let's put these numbers together. 1.4 times 4.3, and put the powers of 10 together. 10 to the third power times 10 to the second power. All right, try to do it from there, Caleb, and then I'll do it and let you see if you got it right in 2 minutes, okay? Anybody else have a problem you want to go over? Or want me to do one-on-one? Sydney, you got to sit all the way up tall. Shamaya, you got your earbuds in?
Yes, ma'am.
Are you writing everything I'm writing on that video?
Yeah. Which one is it?
Thursdays. Go to Thursday in Canvas.
Thursday, Canvas.
Go to the home page for Algebra 1B in Canvas. There's a calendar on the home page, and look at Thursday.
Yes, ma'am.
November 8th, I think. I have the wrong date on the board.
Oh.
It was the 9th, right? I have the wrong date on the board.
Today's the 12th.
Today's the 13th. Yeah, I have the 11th on the board. I forgot it was a 3-day weekend. I forgot all kinds of things, so I really messed it up. Good. Does anybody have a question on any other problems? Gloria, you're supposed to be watching the video as well. Do you have earbuds? Did I give you a pair? Do you have a pair up here? come on up here and look through and make sure, and if not, then I'll give you a pair. Do you need a pair, or do you have a pair that will work on your Chromebook? Alright, well, look through 6th period and make sure I didn't give you a pair already, and if I didn't, I'll get you a pair. Alright, Caleb, what'd you get?
6.4.
Does that have your name on it? Look for one that has your name on it. What'd you say it was?
6.4 times 10.
Did you do 1.5 times 4.3?
Yes.
Alright, let me see. 1.5
That's what we got,
times.
6.4.
Yeah, so it should be 6.45, right?
Yeah,
So if you multiply,
you just add those things to 10. That'd be fine.
yeah, if you multiply these two, you get 6.45. Now it's times 10. What's the exponent on here, Caleb? 10 to the 5th power. And as luck would have it, woohoo, this is in that range, right? It's greater than 1 and less than 10, so I don't have to mess with that one. That one's already in scientific notation.
It's harder to try to miss it.
Huh?
It's harder that way. This little.
Yeah, it's harder if you have to mess with it, so this one's the easier one. I will give you partial credit, like, on the test. So if you were to get this, I will give you a point or two. Probably won't give you half credit, but I would give you a little bit of credit. But this is how you earn all the points. Here, because it already fell into that range, makes it easier. Do you have any others you want me to do? Alright. Write your name on today's date, the 13th, and the time is 1:29. Be back within 4 minutes if you can be. Just write Aiden on 11:13 there. Just grab a pen out of that thing. Probably that little thin Sharpie, or either one. There's also a black one there. That one's gonna be fat. Zanaya, you have any problems you'd like for me to work? Sam? 31. It's 1:30, yeah. Sam and I are doing 31 if anyone is interested. Let's see. Sam, do you know how to do number 30? Sorry? You know how to do 30? Okay. What'd you do for 30? How'd you get the correct answer for 30?
Just add 8 to the thing.
So you did what?
Just add 8 to the box.
Okay, but this one has 3, right? So we could use, what if we use an x here if we don't know it? So it's x plus -5 equals 3, right? So if we add 5 to both sides, that's how we'd know that the exponent is 8, right? So here we can do the same thing kind of, but we're going to have to combine these. So let's do m. Now let's add these exponents and combine those first. So that's m to the 1/3. So we're going to do 1 ABC 3 plus 1 ABC 6. So now we know that's m to the 1/2 times m, we don't know, equals m squared. Does that make sense? Does that make sense, Sam? So we just combine those first. So now we can just write the equation. We're going to use x for that, 1/2 plus x equals 2. So we're going to subtract 1/2 from both sides. And beauty of the calculator is, now we can use the calculator to subtract. 2 minus 1 ABC 2 equals, and it says 1 1/2, but we want it as an improper fraction. So I'm going to hit second ABC. So x equals 3/2. So now we know that that exponent is 3/2. Does that make sense? We have to combine the ones and rewrite the problem.
What did you get 3/2? Did you like?
Subtracted, so this was 1/2 plus x equals 2, right? We've got to get rid of the 1/2, right? So it's a positive 1/2, so we subtracted 1/2, right? 2 minus 1/2 on our calculator told us it was 3/2. You may want to practice it on the calculator. I'll write the buttons down for you. So if you want to use your calculator, it's going to be 2 minus 1 ABC 2 equals, and then it's going to tell you that it's 1.5, but we don't want a mixed number. So then we're going to hit ABC button again, and it's going to tell us that is 3/2. Armani, you're supposed to be working, buddy. Amari, are you watching the video again?
I am. I think I am. I'm watching the right one?
Oh, I said Amari.
Oh.
I did not look to see, but I can. I'll check for you.
Am I on the right video?
It's coming up. I don't know yet.
Oh, I thought you were.
Yeah, I'm looking right now, but my program is loading.
Guess what?
Yeah, you're on the right one.
The second
Amari, oh, you're Aiden, work on yours, buddy.
Huh?
Let's work.
Oh, I had one about
I know.
I was dreaming about going to sleep.
Come on, buddy. I need you to dream about making an A on this test. And by dream, I mean work hard and get all the practice so you can do well on the test. Faith, do you have any problems you want us to work together? No? Sydney, sit up tall for me. Taj, you gotta be working, buddy. You can't just be sitting there. Aiden, you're not helping me. Taj, pick up your pencil, buddy, and get started. I'm happy to work a problem with you, or two, or three, or four, or five. Any problems you want.
Can we do one of the shape ones? I want to get those.
Oh yeah, let me give you a hint on the shape ones too, because you guys are doing the odd ones this time. So let me give you the formula for the odd one for the odd ones. So the formula for the area of a rectangle is the length times the width. That means it's going to be this times this, right? And the formula for the area of a triangle is the area equals the base times the height divided by 2. And this is the base. I'm sorry, I lied. That's the height, and this is the base. Which one you want to do, Aiden?
The hardest one.
Do you think 35 is the hardest? We'll do 35. All right, so we're going to plug in. We don't know what the area is. That's what we're looking for. So the base, which is 2b squared minus 4. It says times the height, but I want to put my height in front. It doesn't matter. The order doesn't matter, remember, so I'm going to stick my height in the front because I don't like to distribute from the other side. So the height is 5b. Does that make sense? Oh, and then we're going to divide by 2. Always forget to divide by 2. So do you see where we got that expression or that equation, Aiden?
Yes.
All right. So now we're going to distribute. Tell me what you get in the top once you distribute. (5b) times 2b squared. 5 times 2,
10.
okay? And then b times b squared.
No, like 1.
You don't see that, remember it's got a 1 on it. So b times b squared. B to the first times b squared is what?
That's 2. Wait. Let me use my calculator.
What's the shortcut for multiplying expressions with the same base?
Add the exponent.
Right. So what are the exponents here?
2, 3.
Yes. So this would be 10b cubed minus 5b times 4. What's 5b times 4? 20 what? 20b, that's right. 5 times 4 is 20, but it's 20 b's. We have 4 groups of 5 b's and we'd have 20 b's, and it's all divided by 2. You with me?
Yeah.
So that's going to be, I'm going to rewrite that as 10b squared divided by 2 minus 20b divided by 2, because we're dividing both sides by 2, or both expressions by 2. So that's just going to be 5b squared minus 10b. You with me?
Mm-hmm.
Alright, so you try that one on your own.
What you mean?
33.
I mean,
You don't have to divide that one by anything. Jalen, you see any problems you want us to do together, buddy? No. Are you doing problems?
I know one.
Okay.
It's 47.
47? Alright. Simplify each expression. I'm going to rewrite it right here. So it's going to be negative 2x squared times negative 3x to the 1 half plus 5. So what do you think we're going to do, Aiden? Very good. We are going to distribute. When we distribute, we're going to do this number, the coefficient times the coefficient. So negative 2 times negative 3. Do that on your calculator. 2 negative button times 3 negative button. You should get positive 6.
Ooh. Alright, yeah.
Okay, now we're going to do the x's times the x's. So it's x squared times x to the 1 half. So what's the shortcut?
Add them.
Adding what?
The exponents.
Right, so we want to add 2 plus 1 half. Remember how to do that on your calculator?
Yes. Two, 1 half.
Be 2 and 1 half, but we want to leave that for the exponent. We want it as an improper fraction. So now I press the ABC button again. What'd you get? So 2 plus 1 ABC 2, and you'll get 2 and a half, right? Now press the ABC button. Oh, I lied. Second, then ABC button.
5, 2.
5 halves, yeah. So we know that is 5 halves. So we're going to get 6b to the 5, not b's, x's.
Well, what is the meaning?
X to the 5 halves. Now it's negative 2 x squared plus 5. So what's that going to be?
Negative what?
We've already distributed it to the first term. Now we're distributing it to the 5. What's that going to be?
Teachers and students, please pardon this interruption. Students, if you have football conditioning, 7th period. You should report to the cafeteria when the bell rings. Once again, Mr. McGriff's 7th period class should all report to the cafeteria when the bell rings. Thank
So
you.
I could do that on the calculator, right? I do.
Yep, negative 2 times
negative
5.
2 times 5. Oh, negative. Yeah, negative 10.
Negative 10. And now there's nothing to multiply the x squared by, so we just bring it along. So we have 6x to the 5 has power minus 10x squared. We can't do anything else. We can only subtract or add things at the same exponent. So they're both x's, and we could multiply them, but we can't subtract them. So that's the final answer.
I got one more.
Okay? Any questions on that one, Jacob? What's your other one, Aiden?
40.
40? Alright, so this one we're going to rearrange. You're going to put these together. We did this one on Thursday.
Oh, we did. We'll do another one.
Okay, which one you want to do?
42.
Okay. Alright, so we're going to rearrange this one times this one. 0.2 times 0.4, right? Now what?
And then we will do the 10, 11, and then 10, 14, but negative 14.
Negative 14. Okay?
And then we would divide the first one, that would be 8. I mean, no.
Not divide them.
Yeah.
We're multiplying, right?
Multiply.
0.08, right?
Mm-hmm.
Double check. 0.2 times
Yeah,
0.4.
it's
Yep. And that's times 10 to the watt power.
How would that work?
So remember,
Oh wait, we got okay. My problem.
what are we going to do with those powers? Exponents?
Put on the box.
So scientific notation is the only time we can leave it as negative, right? So we're going to, remember, the shortcut is to add the exponents. So 11 plus 14 negative, but on your calculator tells you it's going to be negative 3. What's the problem here though, Aiden?
Yeah, negative.
No, that's okay in scientific notation. It's the only time you can have a negative exponent is when it's in scientific notation.
8.
Yeah, this has got to be greater than or equal to 1, but this is not, is it? It's not. So we're going to have to rewrite that one. So this time we don't go to the left. If we go to the left, it gets smaller. So right now it is less than 1. Would you agree? So we know it's going to be times 10 raised to the negative something power, because it's already less than 1, right? We're going to move it how many places? If we move it here, is it greater than 1 yet? No. We move it here. Now it is. So now it's 8. And how many times did we move it? 2. So now it's 8 times 10 to the negative 2 power. Does that make sense?
Yeah.
But we can't forget we've got this 10 to the negative 3rd power left. So now we need to combine these. Caleb Davis?
Wouldn't that be?
Not working, buddy.
That would be 8 times 10 to the negative 5.
That's perfect, yeah. All I know, Caleb, is I'm looking over at you and you're sitting there with both hands on your chin. You're not doing anything.
Which is like 1 minute.
Okay, well, I'm going to come look at your paper and see how much work you've done. Okay, so that one, you started it. Did you finish it? Oh, there it is over there, right? How am I didn't know that? Because you got that one by that one. All right, so remember, everybody's gonna be bringing your Chromebook every day.
Remember, how long you be teaching?
What, buddy?
How long you be teaching?